power series are extremely important in mathematics. They appear, for example, when we study differential equations, and we also use them to define very important functions. Later in this playlist, we'll see how we define the exponential function as a power series. But also, sine and cosine are defined again as power series. So, first, well, to be able to talk about them, we need to know what a power series is. A power series is just a series of the form of the sum from n equals 0 to infinity of an times xn, where x is a variable and the an's are just constants that we call coefficients. So power series looks just like a0 plus a1 times x plus a2 times x squared plus a3 times x cubed and so on. So if you look at it, it just looks like an infinitely long polynomial. That's what it is. A power series is just an infinitely long polynomial. And here we're just summing powers of x. That's what it's called, power series. And here there's some important things to note. First one is that we're using the convention that x to the 0 is equal to 1 even when x is equal to 0, just to avoid problems at x equals 0. And also you see when x is equal to 0, the power series always converges, because when you plug in 0, what do you end up with? Well, you have a0 plus a1 times 0 plus a2 times 0 plus a3 times 0 and so on. So it will be just a0. So we know that given a power series, it is convergent at least for x equals 0. It might be convergent for more values of x, but at least we're guaranteed that it is convergent for x equals to 0. And here is an example of a power series that you already know. If we take all the coefficients to be equal to 1, we end up with the geometric series. And we know that it converges to 1 over 1 minus x when the absolute value of x is less than 1, and it diverges when the absolute value of x is greater than or equal to 1. So here's an example that we see that we have a power series that is convergent in some interval, in this case the interval -1 to 1 is open at both ends. But well, what happens in general? Well, that's something that we're going to study later in the playlist. For now, let's take a look at this one. For what values of x is the series given by the sum from n equals 0 to infinity of x to the n over n factorial convergent? Well, to study power series, one of the best tools we have is the ratio test. It makes our life very easy. We're going to use the ratio test with an equals to x to the n over n factorial, and we create now the ratio of an plus 1 over an and put in absolute value, and we have to just construct this. It's look big and chunky. We're going to massage this expression to make it a bit more manageable. So we end up with n factorial over n plus 1 factorial times absolute value of x to the n plus 1 over absolute value of x to the n. So here there is quite a bit of simplification that we can do. We can have, well, this is n factorial over n plus 1 times n factorial times the absolute value of x. So the n factorials will cancel, and we end up with 1 over n plus 1 times absolute value of x. So if I take a look at the limit as n approaches infinity of this, remember, x here is a fixed number, so it will not affect. If I take a look at this, well, what happens is, well, as n approaches infinity, 1 over n plus 1 goes to 0. And absolute value of x is a fixed number, so we have a number times something that goes to 0, so this limit is 0. And 0 is less than 1. And as we said, this works for any value of x, no matter what x is. So then my power series converges for any real number x. And actually, this is how we define the exponential function. The exponential function, like e to the x, is just the sum from n equals 0 to infinity of x to the n over n factorial.